Hello busy people, welcome back to my channel Leetcode for you. Today I am going to solve daily Leetcode challenge lexicographical numbers. The question states that given an integer n, return all the numbers in the range of 1 to n sorted in lexicographical order. We must write an algorithm that runs in big O of n time and uses big O of 1 extra space. We are provided with two examples along with constraints. Let us talk about constraints. The constraint states that the input value n should lies between 1 to 5 into 10 power 4. So, first we'll speak of what is meant by lexicographical order. So, lexicographical order is akin to how words are arranged in a dictionary, where the sequence is based on alphabetical order of their component letters. When applied to numbers, it means ordering them as if there are strings where 10 comes before 2 because 1 comes before 2 in the lexicographical sequence. So let us discuss with an examples to get a clear-cut idea how to solve this problem. So first we'll take example 1. So in example 1 we are provided with input value n is equals to 13 and we have to generate a sequence which is between 1 to 13. So between 1 to 13 we have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and we have to generate a lexicographical sequence with these numbers. So we have two solutions here. So first solution is to convert them into strings and sort them. After sorting we'll get a lexicographical order, but these solution takes big O of n log n time complexity, which is for sorting, and we are not using any extra space for this because we are using only sorting. So our time complexity is big O of n log n, but in question they have clearly stated that we have to use big O of n time complexity to solve this problem. So we have to generate an algorithm which solve this problem. So for that, first we'll try to take an example and explain it with an example. So we'll take a sample example like n is equals to 25. So for this we'll generate all numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20. Now we have to find lexicographical order for this sequence, which is from 1 to 25. So for this I'll make use of a list which is later returned as a final result. So in this list I'll just add our current number as 1. Later I'll check this current number has any multiples of 10 which is in the range of 1 to 25 or not. Yes, the current number has multiples of 10 which is 10 value which is in the range of 1 to 25, so I'll add it in the list. So later I'll check by incrementing the number 11 which has any multiples of 10 within the range of our specified n value or not. No, it don't have any multiples of 10 within the range, so I'll just increment the number. So for 12 also there is no multiples of 10 within the range of 1 to n, so I'll move forward and increment by 1. So I'll do it same until I'll get 19 as our current value. So here we'll get a base case value in which if we have 19, then if we increment it by 1 we'll get 20, but according to lexicographical order before 20 we'll get 2 in the sequence. So for that I'll do one base case value, like if our current value modulo divisible by 10 equals to 9. Then I'll just make our current value divisible by 10, so that I'll get our current value as 1. Later on I'll just increment our current value plus 1. So in this case we'll get 2 as our number after 19. Later we'll check whether these two contain any multiples of 10 or not within the range of 1 to 25. Yes, we have that numbers, like we'll get 20 as the multiples of 2. Later we'll check by incrementing the current value, which is 21, and we'll check any multiples of 10 within the range of 1 to 25. No, we don't have any numbers, so we'll move forward by incrementing it with 1. So until we'll do it until 25. So next, after 25 we don't have any value if we increment it by 1. So if we increment it by 1, we'll get 26, which is out of bounds of specified value. So here we'll get another base case. If we don't have any number which is less than 25, then current value plus 1 is greater than n value. Then also we'll do the same, we'll just divide it by 10, so that we'll get our current value as 2. So we'll move to next number in the lexicographical order. Like current value is 2, then we'll have to increment it with 1. So current value 2 plus 1 will get as 3. So in our order we'll just mention 3. Then we'll check multiples of 10 for this number. Like we don't have any multiples of 10 which is in the range of 1 to 25, so we'll move forward by incrementing with 1. So we'll do it same for this number 4. We don't have any multiples of 10 which in the range of 1 to 25, so we'll move forward 8, 9. So here we have moved to all the numbers in the sequence, and also we have generated lexicographical order of this sequence. So in the same manner we can generate lexicographical sequence for our example 1, like 1 to 13. So first we have to take 1 in our list. Later we have to check whether this 1 value contain any multiples of 10 within the range of 1 to 13 or not. Yes, we have the multiples of 10. Later we have to check is there any numbers present multiples of 10 which is 100 in the range of 1 to 13. No, there is no such numbers, so we have to move forward by incrementing our current value, which is 11, and also we have to check the same it has any multiples of 10 in the given range or not. No, it doesn't present any value, so we have to move forward by incrementing our 11 value. It is 12. We'll do the same for this number. We'll do for 13. So here after 13 we have number 14 which is out of range, which is specified by the n value, which is 13. So we'll just divide it by 10. So 13 divisible by 10 will get as 1. So we'll move forward by incrementing the current value, which is 2. So later if we have any values which is multiples of 2, no, we don't have any values, so we'll move to 3, 4, 5, 6, 7, 8 until 9. So in this manner we can generate our lexicographical order. Let us code same in the Java. So in the question we have to return a list of integers which are in lexicographical order. So for that, first I will create a list which store integer values. Array list. So I'll use a variable which is called current num initialized to 1. So with this variable will generate every single value in the lexicographical order. So for that I'll use a for loop I less than equals to n value I plus plus. So initially I'll just add our current num value to the list. Later I'll check if there present any current value multiples of 10 within the range or not. So if there present any current num value multiples of 10 within the range, then I'll just update our current num value to that multiples of 10. If we don't present any multiples of 10 within the range, then I'll just increment our current value plus 1. So if we move further, we'll increment it by 11. So I'll check any multiples of 11 present within the range or not. So we don't present any multiples of 11 in the range, so I'll just add it to the list. So in the same manner I'll just add 11, 12, 13, 14, 15, 16, 17 and 18 and till 19. So after 19 we'll just move to 2. So for that I'll use a base case, like if we have any numbers as 19, 29, 39, 49 etc., then we'll just modulo divisible equals to 9, then we'll just make our current num divisible by 10, so that if we take 19 then we'll divide it by 10, so we'll get our current num value as 1. Later we'll just increment it, we'll get our current num as 2 and we'll add it to the sequence. So after 19 we'll add 2 in our sequence. So we'll move further. So if we will move further, we have any multiples of 10 for the current num or not within the range. So we have current num within the range of 25. So we'll just add that current number which is 20. So we'll move on to until further any number which is exceeded or not. So until 25 will. So after 25 we'll just increment it with 26. So 26 it exceeds our n value, so we'll make another condition. So in that condition we'll just add current num value which is 25 plus 1, which is greater than n or not. If it is greater than n, so again we'll do the same, like we'll divide it by 10 so that we'll get our number as 2. So later we'll just increment it by 1. So we'll move to 3 and we'll add that 3 to our lexicographical sequence. So in this manner we can just add all the numbers which are generated according to lexicographical sequence. So at end we'll just return our list. So we'll try to run it. Successful, and try to submit it. 42% faster.